Now we'll take a look at the filament runout feature in Marlin. As we continue our trek through the Marlin firmware, we're going to check out the filament runout sensor feature that's available in Marlin. Some of you are saying, Chris, you've already done filament runout sensor. And that is true. But that one was designed to work with Octoprint. This one will work with your main board and Marlin natively. We are going to test it on the ramps board, but it works on a lot of different main boards. You will have to have M600 enabled for this to work, which you can check out a video on how to do that here. You will have to have some sort of switch. I'm going to be using the standard 3-wire end-stop switch, and a case that I found on Thingiverse. Links to all this in the description below. Now let's head into Marlin and see how to get this configured. So we'll head into Marlin, we'll open the marlin.ino file. This Marlin is configured for this printer already, and it's version 1.1.8. So let's touch on the M600 configuration first, just for a moment. Let's head into configuration_adv.h. Let's do a find on M600. M600 is the process that the filament sensor will execute when it gets triggered. This is where you'll set all this up. Again, this is in another video that I've already made previously. Now let's head to the configuration.h tab. Let's do a Control F and do a find on nozzle park. Also, when setting up M600, this is the location where the nozzle will be parked at. Now we can get to configuring the filament sensor. Control F. Let's search for runout. You can see in the comments that ramps-based boards use servo pin 3 by default. We can take a look at that in the ramps board file in a moment. When you have your M600 command enabled, this is going to do most of the work for you. So when your filament sensor is triggered, it's going to run the M600 script, basically just executing that command. So let's remove the comment from define filament runout sensor. And the only setting we might have to play with is the switch logic. This is the setting that you would change if your switch is normally closed when filament is present, or normally open when filament is present. We'll start with false and test it out. If we need to change it, we can come back later. After you have M600 set up, this is really all you need to do to set up the filament runout sensor. Let's head over to the board configuration tab just to see what's in there. We'll go to the pull down, and we'll scroll down, and we'll take a look at pins_ramps. So this is the configuration that says what all your board pins do. If you start scrolling through this configuration, the first thing you'll come to is servo 3. We're using pin 4 for our filament sensor. By default, servo 3 already has pin 4 defined, but that's only if servo 3 is enabled. More than likely, you're not using any of your servo pins on your main board. And if you were using those servo pins, you'd probably already know it. If you jump back over to configuration.h and you scroll all the way to the bottom, this is where your servos would be configured. By default, they're always commented out, so we know that pin 4 is available for use. Let's go back to pins_ramps.h, and we'll scroll down a little further, and we'll find define fill runout pin. It is also configured for pin 4. Since we have removed the filament runout sensor comment in configuration.h, pin 4 is now enabled for the filament runout sensor. If you need to use a different pin besides pin 4, you would need to confirm that that pin is not currently in use, and then you would edit that pin here. So if you take a look at the ramps pinout, this is the servo section right here. This is pin 4. This is the default pin for our filament runout sensor. Say you were already using pin 4 for something. We could use pin 11. That's servo 0. So back into pins_ramps, we would need to confirm we're not using pin 11. Pin 11 is defined for servo 0. We have servos commented out, so you could change that filament runout pin to 11 and use that port. You would just change this 4 to 11. Since we're going to be using servo 3, I'm just going to leave it at default for 4. Now we're done with the Marlin configuration part, so let's go ahead and verify. And if the verify looks good, go to Tools, select your main board, 2560 for me, select your COM port, and hit Upload. Now the upload's complete, let's wire up our switch to our ramps board. Now there's a lot of great cases available on Thingiverse for these little end-stop switches that are connected to the PCB. But I like this one. It just fits in here just like this, and we're going to use a couple of M3 screws and nuts to connect it. So now my in-stop switch is in my case. Here's my spare ramps board and the mounted switch in the box. Here's a very important step if you're going to use one of these pre-configured in-stop switches. These switches are pre-configured to work as in-stops. So the wiring is going to be positive, negative in the center, and then signal. And if you look at the in-stop connections on your board, that is correct. It's signal, negative in the center, and positive on the other side. That is not going to be the proper configuration for a servo. The servo is signal on the top right here, positive in the center, and negative on the outside. So basically, if you want to use this pre-configured switch, you're going to need to swap the negative and the positive. Now, if you're really careful, you can take these plugs off of these wires and swap these two wires. But it's probably best if you replace this DuPont plug altogether. If you want to try disassembling the plug, you can pull these tabs back really gently and swap those two wires and try to put them back in the best you can. And this is what it needs to look like to be used as a filament sensor on your servo plug. So after you swap those two wires, it'll go right here on pin 4, the support for servo 3, just like that. Signal on the top pin, positive in the center, and negative on the outside. Some of these switches have LEDs that light when they're triggered. Note that's not going to happen in this configuration. Servo pins do not provide 5 volts to that pin by default. Really all we need for this configuration to work is this signal pin and this ground pin. And that's all the wiring you have to do to get your sensor hooked up. It's really hard to see inside my control box, but my servo pins are right here. And I'm going to hook up my filament sensor just like we did to my spare ramps board on the pins that support servo 3 normally. Right there. And I'll just run them through the top. And we can close the door on the control box. So the first thing we need to test before we even load any filament is to make sure that this switch's logic is correct. We can alter that in Marlin like I showed you before. We need to know that if this switch is disengaged, the M600 command will get ran, and when it's engaged, nothing will happen. So to test this out, we'll just leave the switch open and start a print and make sure that it goes through the M600 routine correctly. So the printer started printing without any issues, and there's no filament present. So the logic on our switch is incorrect. We need to go into Marlin and correct that. So we'll stop this print, we'll head back into Marlin, and we'll change our fill runout inverting to true. This will set the switch logic to work the other way. And let's go ahead and re-upload. Our logic is corrected. Now let's start that print again with no filament and see what happens this time. This time you can see when it started the print, it automatically issued the M600 because there was no filament present. The printer beeps and notifies you that you need to load some filament. So let's load our filament through the sensor. That'll trigger the switch, and then on into the extruder. The filament's loaded and the sensor's set on top of the extruder. We can go ahead and hit the LCD button. It will heat the hot end back to normal printing temperature. Now it's loaded the filament and primed the nozzle. When you're happy that it's extruded enough filament for your filament change, you can go ahead and click resume. And now your print's printing successfully. Now let's say you run out of filament, or something bad happens. The filament sensor just got triggered. M600 just executed. It pushed out the remaining filament and has alerted you that it needs to be changed. We'll pull out the old filament. We'll reload our filament sensor, reload our extruder, hit the LCD button, confirm that our filament is extruding, which it is, and click resume. Right back to where the print left off, and the filament sensor has saved your bacon. I'm just letting my sensor ride on top of the extruder for this tutorial, but you can mount these however you wish. You could probably even set it up here if you like and it'd work out well, just as long as the filament path is pretty straight to the extruder. There's lots of different mounts for these switches and different filament switches on Thingiverse. You can use one that fits your printer. And there you have it. Another great feature that's baked right into the Marlin firmware that's pretty easy to set up. Did I mention that Marlin is free to use and gets updated constantly? It's free to use. I hope you found this video helpful. If you did, please consider giving it a thumbs up or subscribing to my channel. If not, leave your thoughts in the comments below, and thanks for watching. I think I need some screws out of my sweet new screw holder.